Hi everyone, Miss Caulfield here. In today's video, we are going to be looking at the subatomic particles and how they were discovered, as well as how subatomic particles are represented on element symbols. So getting started, there are three subatomic particles that exist. We have protons, neutrons, and electrons. Protons and neutrons are about the same size. We say that they are each 1 AMU. An AMU is a unit called the atomic mass unit. So when scientists were trying to look at the masses of atoms and elements, atoms of elements, as well as the mass of these subatomic particles, the mass is so small that they had to develop their own unit to measure the mass, and that is known as the AMU, the atomic mass unit. So protons and neutrons are relatively the same size. Electrons are much smaller. They have a relative mass of 0.0005 AMUs. So when we think about the mass of the atom, the majority of the mass of the atom, or the entirety of the mass of the atom, is coming from the protons and the neutrons. Protons have a positive charge, neutrons have a neutral charge, or a charge of 0, and electrons have a negative charge. If we take a look at the image in the top right corner here, we are looking at a quantum model of the atom. We notice there are two general locations, the nucleus and the electron cloud. Protons and neutrons are both located in the nucleus, whereas electrons are going to be located in the electron cloud. And then you could also see protons, neutrons, and electrons abbreviated by just their symbols. So the proton symbol is going to be a P with a positive sign. The neutron symbol is N with a 0 to show its neutral charge, and electrons is an E with a negative sign. So it was once thought that the atom was the smallest piece of matter that could exist, but over time scientists have discovered that there are things smaller than the atom, and those things are what we call the subatomic particles, the protons, neutrons, and electrons. And so their discovery was really important because it helped shape our understanding of how atoms function, and atoms make up all matter. The electron was discovered by a man named J.J. Thomson, and he discovered the electron by using a cathode ray tube. And what the cathode ray tube is that it is a beam of particles that are fired between two electrodes. One is a cathode and the other is an anode. That beam of particles is kept inside of a vacuum tube. And what J.J. Thomson did is he introduced a magnetic field to that beam of particles. And what he saw was that when the negative end of the magnet was towards the beam of particles, the beam started to repel away from the magnet. And when the positive end of the magnet was towards the beam of particles, the particles were attracted. And so he realized that that beam of particles were actually consisting of negatively charged particles, and he called those negatively charged particles the electrons. Ernest Rutherford, discovered the proton, and he discovered the proton in the same way that J.J. Thomson discovered the electron. So he also used the cathode ray tube. But he reversed the beam of particles. And so by reversing the beam of particles and having it originate at the anode instead of at the cathode, he actually changed the charge of the particles in the beam and realized that those particles were now positively charged, and he termed those positively charged particles the proton. The last subatomic particle was discovered by a student of Ernest Rutherford's. His name was James Chadwick. And James Chadwick discovered the neutron through a series of experiments with a beryllium atom, but that experiment is a little bit higher than what we need to know for this class, so you don't need to know how the neutrons were discovered, just who discovered them. The last important thing about an atom was the discovery of a nucleus, that small dense center. The nucleus was discovered by Ernest Rutherford, and he discovered the nucleus through a very important experiment called the gold foil experiment. And the gold foil experiment was when Rutherford fired a beam of alpha particles, so think about them as like small spheres, at a piece of gold foil. Well, it was originally thought that the atom was a small, dense sphere. So if those small alpha particles were fired at the gold foil, it was predicted that none of the particles would be able to go through the foil. But that's not what the scientists saw. They saw that those particles actually did pass through the foil and were detected on the other side. But not only that, they also saw that those particles would bounce off of each other and deflect at different angles, or even bounce all the way back. So because some of those particles were actually being deflected at different angles or bouncing back, this led Rutherford to the idea that most of the atom is actually made up of just empty space, but at the center of an atom is a very small, dense nucleus. And that small, dense nucleus is what was causing those alpha particles, when they collided with the nucleus, to bounce off at different angles, or to even bounce all the way back and be detected on the same side of the gold foil. But most of the particles ended up passing through and being detected on the opposite side of the gold foil. So the big experiments to know for this unit are the cathode ray tube and the gold foil experiment. If you're interested in learning more about those, there are a lot of great YouTube videos that demonstrate how those two experiments were conducted. So now that we've learned a little bit more about the discovery of the subatomic particles, we're going to be looking at how those particles are depicted in the different models of the atom over time. So the first model of the atom was proposed by a man named John Dalton. And John Dalton's model of the atom is often referred to as the solid sphere model, or the billiard ball model. In John Dalton's model of the atom, he believed that the atom was the smallest form of matter that could exist, and that the atom was just a dense sphere. It was just a dense ball, and there was nothing smaller than the atom. Well, as you may know, as we've just talked about, there are things that make up an atom. There are things that have been discovered that are smaller than the atom. And the first subatomic particle that was discovered was that of the electron. So the electron was discovered again by J.J. Thomson. And so J.J. Thomson proposed what's called the plum pudding model. And in the plum pudding model, we see electrons appearing for the first time, because he based his model around the discovery of the electron. So all of these negative charges here are representing electrons. The reason this model is called the plum pudding model, plum pudding is a very common British dessert, and J.J. Thomson is in fact British. You can kind of think about plum pudding similar to a blueberry muffin. The blueberries within the muffin are the electrons in this model, and then the rest of the muffin was this positive charge that was kind of dispersed throughout the entire atom. After J.J. Thomson's model of the atom came Ernest Rutherford's model of the atom. Remember, Rutherford discovered the nucleus in his gold foil experiment. So this model of the atom is often referred to as the nuclear model. And while it's not a subatomic particle, it is important to note that this is the first time that the nucleus is appearing in the different models of the atom. Now, we do still see electrons on the outside of that nucleus too. After Rutherford's model, after he proposed that model, he started to do more work with subatomic particles, and he discovered the proton, and his student James Chadwick discovered the neutron. And they helped work with a man named Niels Bohr to develop what is known as the planetary model. So Bohr's model of the atom is the planetary model of the atom. Here we do still see the nucleus, but here we see neutrons and protons within the nucleus, and then we see these electrons on fixed orbits orbiting around the nucleus. So this is really where protons and neutrons first appear. After studying the atom even further, scientists like Einstein and Schrödinger and Heisenberg all worked on particle physics and quantum theory, and they discovered what is referred to as the quantum model of the atom. The difference between the quantum model and the planetary model is that instead of having the electrons on a fixed orbit, we now see the electrons in this electron cloud. So we have electrons in an electron cloud versus electrons in fixed orbits. So as mentioned on our last slide, John Dalton was really the first scientist to come up with a model of the atom, that solid sphere or billiard ball model. And as he was studying the atom, he came up with these 5 principles of atomic theory. So the first principle is that all matter is composed of extremely small particles called atoms, that atoms of a given element are always going to be identical in size, shape, and other properties, that atoms cannot be subdivided, so there is nothing smaller than the atom, or atoms cannot be created nor destroyed. Atoms of different elements can combine in whole number fixed ratios to form compounds. And lastly, that in chemical reactions, atoms are going to be combined, separated, or rearranged. Well, these are pretty impressive principles for the first person to really propose anything about the atom. And of these 5 principles, 3 of them are still true today, but there are 2 principles or 2 statements that we know no longer hold true. The first of which is statement number 2. In statement number 2, it says that all atoms are going to be identical in size and mass, but we know that things called isotopes exist. And because isotopes exist and isotopes have different mass numbers, we know this is not true. The other statement that is no longer true is statement number 3, that atoms cannot be subdivided. As we've learned in this video, subatomic particles do exist, so that is no longer true. All right, so great job, guys, for looking at how the different subatomic particles were discovered and how they are depicted in the different models of the atom.